Hello everyone. Gather around because I have a secret to share. Well, I have something cool about AWS Secrets Manager to share. Welcome to today's session where we'll take a closer look at how generative AI can help your developers build secure applications from get-go. My name is Akshay and I'm the product manager for AWS Secrets Manager. In today's session, we'll start by understanding the need for a secrets management solution. Why do you need one in the first place? Then, we'll see how generative AI can empower developers in your organization to build secure code from exactly where they start their coding journey. After that, we'll take a closer look at one of the recent launches from AWS Secrets Manager that help you become prescriptive about how you consume secrets across your workloads. And lastly, we'll see how admins can monitor compliance and build governance on your secrets using the power of generative AI. So, let's get started. Need for a secrets management solution. If you look at common weaknesses to enumerate, top 25 most dangerous software weakness list, you'll find hard-coded credentials at number 18. What does this mean? This essentially means that when you're building your applications, you need to avoid hard-coded credentials. Your secrets should be away from your application code. Is that sufficient? Well, our secrets can be seen away from the code as well. We have to encrypt them as we store them. On AWS Secrets Manager, every single secret that you store is encrypted using a KMS key, which is FIPS 140-2 level 3 security validated. And now our secrets are stored somewhere else, our applications are running somewhere else. If we want continuity for our businesses, we want our secrets management solution to offer high-scale retrieval exactly the way our applications need for our secrets. And lastly, because our applications rely on these secrets for their execution purpose, we need a mechanism through which we can have some sort of a disaster recovery so that our applications don't see a downtime when it comes to fetching secrets. Now, these are the reasons why we need a secrets management solution. But how can one add value to your business? Let's go back in time for that. Somewhere between 2012 and 2013, as the internet industry was maturing, the compliance standard became more prescriptive in nature. And what I mean by that is compliance standards started dictating you need to rotate your secrets every 90 days, every 30 days, depending upon the type of secrets. On Secrets Manager, rotation is a 4-click process. Enable rotation, define schedule, give the name, and submit. That's it. That's how you set up rotation on Secrets Manager. Next, another way compliance standard became prescriptive was by saying you cannot have overly permissive secrets. You need to build separation of roles. You need to make sure who can read the secret, who can write to secret, who can rotate secret, who can update a secret. On Secrets Manager, you can achieve separation of duties with a combination of IAM policies, resource policies, and attribute-based access controls. And lastly, secrets are the key to your kingdom. They protect the most important asset for your organization, which is your data. We need 100% transparency on what happens with our secrets at all times. So, a secrets management system can add value to your business if it's able to give you full visibility with what happens with your secret. On Secrets Manager, we log every single action that happens on secrets into CloudTrail. And soon, we'll see how we can leverage all of that and top of it with generative AI powers to build anomaly detection. Let's switch gears a bit. Let's step into a developer's shoe. Let's say our developer is tasked to build a simple Lambda function application to write a code which connects to a database and fetches some data. And you would see over here, our developer hard-coded the secret. How can we meet our developer right here and tell them not to do this? They should be avoiding such type of vulnerabilities starting exactly where they code. Introducing Amazon Q developer plugin for your Visual Studio IDE. With that, as you're typing your code, the Amazon Q will prompt you, hey, you have a hard-coded credential, you should not be doing that. This is a common weakness that in your code. And that's how you meet developers where they code and tell them to write better code from the moment they start coding. We told the developer what not to do. We have to tell them what they should be doing instead. How do we do that? Within your Visual Studio window, Amazon Q also opens up a chatbot. You can use this chatbot and simply ask, how do I replace hard-coded secrets and use Secrets Manager instead? And what happens with that is the Amazon Q chatbot actually refactors the entire code for you. It gives you exact lines of code that you need to replace in your existing code from the context that it has in your Visual Studio window and tells you what changes you need to make. It also goes on and tells you how you can appropriately vault this secret in Secrets Manager and set up the configuration for your Lambda function environment to fetch this secret. It also tells you how you can appropriately scope the permissions for your secrets so that they can easily be fetched inside your compute. Lastly, the chatbot also tells you what are the benefits of this approach. As you can see, point number 2 over here, our secrets are encrypted at rest and also in transit, which means KMS key is protecting my secrets while they are stored, but until your application needs to read that secret, they are encrypted in transit as well under the TLS layer. And secondly, because your secrets are stored somewhere else, rotation is an asynchronous process. Whenever your application needs secret, they always get the latest value of secret. And that's how Amazon Q Developer meets developers where they code and help them build secure applications. Let's move on. We said our secrets are away, our applications are somewhere else. What do our applications need? The first thing our applications need is they do not want latencies when it comes to fetching secrets. You can't have your application slow down because they're taking time to pull secrets. You need a very high availability of secrets in your code. Secondly, your secrets are rotating, let's say, every 24 hours. You would not want to redeploy your code every 24 hours to be able to get the latest value of secrets. You want your secrets to be fetched, updated, and available. You don't want downtime for your applications. And lastly, you do not want your developers to focus on writing like 50 lines of code to fetch secrets. You want them to focus on actually building the applications. How do we solve for all of these challenges within AWS? Introducing a new feature from AWS Secrets Manager that we call Secrets Manager Agent. Secrets Manager Agent standardizes the way you consume secrets across any type of compute. That's right, it's any type of compute. It works on a Lambda function, it works on an EC2, it works in Kubernetes, containers, and even on-prem scenarios. Secondly, it improves the availability for secrets in your applications by giving you an in-memory caching layer. Your applications can talk to the agent and they fetch the value from a caching layer which is inside your compute, making latencies near zero for your applications. The agent also communicates with your application using an HTTP port. This makes it language agnostic. So your developers can build code in Java, Ruby, Python, whichever language they want. The agent will work for their scenarios. And of course, we're talking about secrets. We have to talk about security. The agent comes in with a default inbuilt protection against server-side request forgery that also ensures who can access your secrets inside that compute environment. If there are multiple applications, you can control which applications can have access to those secrets. Let's take a closer look at the internal workings of this agent and how it changes the way you communicate with Secrets Manager. There's a compute instance, and you have your application running on it. In the previous example, we saw your application was talking to Secrets Manager directly to fetch their secrets. If we were to use the agent in this scenario, you would deploy the agent within your compute. And your application will request for the secret using the HTTP service of the agent. The HTTP server will check for the secret in the in-memory cache and see if it is a valid secret or not. If it is a valid secret, it's going to respond back to your application with that secret. If it is not valid, it's going to call Secrets Manager on your behalf, get the latest value of secret, and then respond back to your application. Notice over here, your application at all times is fetching secrets locally. There is zero latency when it comes to getting secrets. And secondly, because there's a time to live that you have put on the secrets, asynchronously, when Secrets Manager is rotating secrets, your updated secret value automatically appears inside your compute environment for your applications. Now, this sounds like a robust service, which potentially would be too complicated. Well, we empowered the developers again over here by giving them a bunch of configuration options. They can customize the memory footprint of the agent. They can customize what level of logs it controls, what HTTP port it can communicate to, what region it can point to, number of secrets it can cache, number of applications it can talk to, and a bunch more. Now, let's go back to our previous example where we were seeing our code of hard-coded secrets, and we want to use the agent in this scenario. Let's have the AI do the work for us. Let's ask the chatbot on how we can have Secrets Manager agent in this code. The AI chatbot actually tells you how you can install the agent in this Lambda function. Then it goes on to tell you how it can appropriately vault the secrets, set up permissions, and also how you can refactor the same piece of code to now point to your agent instead of the API calls that it was previously making. With this, it also lists some of the key benefits that the agent has to offer. Notice over here, the second point again. It decreases the number of times you are hitting the service through API calls. So it works everywhere, it works with all languages, and it also reduces your cost. By the way, another cool thing, we open source this entire agent on GitHub. You have access to the entire code base of this agent, and you can choose to deploy it the way you want in your environments. We review every single pull request, every single feature request that comes on our public GitHub repo. Feel free to raise requests over there, and we review them very closely. We love to take customer feedback on this. Now, moving on to the last segment of today's talk. We said secrets are the key to our kingdom. They protect the most important asset for our organizations. We need to proactively know in case there is some sort of a malicious activity happening with respect to our secrets. At the same time, we also want to know as soon as they happen. We can't wait for a weekly report to tell us there's a secret sprawl happening for my secrets. And we want enough information about that content so that we can prevent that from happening in future. How do we solve for this in AWS? Introducing Secrets Manager integration with Amazon Guard Duty. As you are probably aware, Guard Duty is a threat detection service for continuous monitoring of malicious activity in your account. Now, Secrets Manager integrates with Guard Duty to offer you similar capabilities when it comes to secret sprawl or secret access. Over here, I'm presenting you a sample finding of how an anomalous behavior is detected by Guard Duty for your secrets. Notice the finding is classified as credential access anomalous behavior. It starts by telling you exactly where the activity happened, what accounts were impacted, what action was taken by the bad actor, what user agent was actually used by the bad actor, and exact IP address, exact location where this activity happened. This information can help you actually tighten your IAM policies, your resource policies, to ensure such malicious activities can be prevented. Now, you do not want to come back every day on your Guard Duty console to see if you have a finding or not, right? Guard Duty integrates with Amazon Event Bridge, and you can automatically get these findings delivered to your mailbox instantly. And with that, you can build an end-to-end scalable lifecycle management for your secrets by starting with using generative AI to empower our developers from building secure code, using Secrets Manager agent to have a very prescriptive guidance to all of your developers in your organization as they're building their applications, and using the power of generative AI to build governance on top of your secret. With that, I'd like to thank you all for attending this session. I'll be here for next 15 minutes in case you have any questions, and please do leave feedback on the app for the session. Thank you.